and I shall be talking about the software implementation of our inverter. So the role of the software is to sense any changes to the inverter output and then respond to those changes to ensure that we have a constant output voltage. It does this by sensing the current and voltage of the inverter and reading it into ADCs, comparing the feedback values from the ADCs to a reference signal to generate an error, feed that error into a proportional resonant controller to produce a control signal, and use the control signals to generate a sinusoidal PWM to provide gating signals to the IGBTs. So for the microcontroller, it was decided to use the Delfino Launchpad. This development board was developed by Texas Instruments and was designed for high performance digital control. In addition to that, it was quite an inexpensive board with hardware that often beat other development boards several times its price. Some of the key aspects of this board that make it appealing are the 200 MHz system clock, the C28 CPU and the control processor, the 12-bit ADC, the 12-bit Sigma Delta filter, which performs the same function as the ADC, 24 PWM channels, and the possibility of using what is called booster packs from Texas Instruments. So what they are attachments that we can attach directly to the Launchpad in order to either enhance the Launchpad or increase its versatility. In addition, the Launchpad, once purchased, comes with extensive resources such as code examples and libraries and easy-to-use software to program. In regards to the sensors, we have decided to use the LV25P sensors for voltage and the LA100P for current. Each of these sensors require an input from -15 to +15 volts. It reads the current and voltage of the output stage of the inverter and converts that to a measurement current. For instance, for the voltage transducer, that changes from 0 to 240 volts to 0 to 10 milliamps, and the current sensor changes that from 0 to 100 amps to 0 to 200 milliamps. This measurement current is then converted to a voltage level from 0 to 3.3 volts and passed through an RC filter, which filters out any frequency that is above 15 kilohertz before it is passed through the analog to digital converter. In the analog to digital converter, it reads the voltage levels that have been sent between 0 to 3.3 volts and stores it as digital values between 0 to 495. This analog to digital converter samples values and reads values into variables every interrupt. However, once it's finished reading these variables, there is some post-processing that is required in order to change the values from the voltage levels to actual current levels of the inverter. For the proportional resonant control,